people who join will not miss out. So the communication channels remain our LinkedIn pages. The recordings will be hosted and available almost immediately on the YouTube channel for you to watch it over and over again. Then we communicate via this email or the alternate Gmail that is for SI Analytics. The learning methodology that you are familiar with, you have experienced in one week already, today is the second live session. We're going to be having 3 more after today. We'll be sharing with you the official guide from Power BI on dealing things you can read to add to the things you heard. We'll be sharing with you both our own recorded YouTube videos and other YouTube videos that we think are helpful. Although over the week, somebody did say some of the videos confused them the more. Forget all those things that have confused you. Open your mind today and follow the class at the pace. Then see if you can complete daily tasks and share whatever work that you have. So let me do something. We're going to be, if I bring in our facilitator today, it's important you get to meet him professionally. Then after that, there's a knowledge check for you. If you like, don't listen. We're going to be testing your knowledge of what you learned from the session today, which I know is going to be very, very impactful. And so I'm going to be sharing his profile. Nothing special I've done than to go to his LinkedIn page to showcase the person that is coming. He's a digital health expert. His name is Michael Selesi. He's originally from Ethiopia, and he has experience working across reputable organizations such as WHO, US Centers for Disease Control, AFINET, African CDC. He has led initiatives. He has built a lot of things with data, and is an expert in Power BI, in Tableau, in R, in Stata, in Python, and other GIS documentation. So if you want to connect with him, which I think is one of the things we do on this platform to get to connect with each other, I've dropped his LinkedIn page there so that I can connect with him, follow some of his work. In fact, if you look at some of the things he has done while he was with African CDC, he has examples of the great things he has created, the great works that he's able to showcase. And I have the singular privilege to bring on board our very own Michael Selesi. You can unmute your, so you let me know, do you want to share the screen? If you want, you have the permission to share the screen from your hand. Over to you, Mr. Michael.
Yeah. Thank you very much, sir. Can you hear me very well?
I can hear you. I can see your beautiful face, sir. All right.
Great. Thank you very much. Thank you for the introduction. Good morning, everyone. I don't know, good evening, where you are from. Here it is midday. I know back home it is in the evening, I think. So good evening, good morning, good afternoon, wherever you are. So my name is Michael, as introduced by Nga. I have been working in public health actually most of the time and focusing on informatics, public health informatics and data science related works with different organizations. And just to tell you before we go to the technical part, Power BI, I taught myself. I had no any chance of getting training like this, an organized training. And that time there was no AI to ask some questions online. So I did download the app, the Power BI desktop, to my laptop, and I started creating some Excel data from my own, uploaded those data, trying and fixing, go to YouTube, looking for some troubleshooting. And that is how I taught myself doing Power BI. And Power BI is very powerful, interesting tool for people who want to have a very good data analysis, data visualization, and sharing. So you guys are lucky at least to have a kind of organized training so that at least you have some guide. But what I want to emphasize is that those trainings that you will have online or in person are not the key if you want to excel in Power BI. You have to practice yourself. These are just guides or give you some basics or highlights or a kind of induction, but you have to have your own time and you have to practice daily until you feel that you are excellent in Power BI. So the more you practice, the more you excel in Power BI. So that is my advice from my experience. I had no any training. I taught myself, but through trying and error, through fixing, asking people, at least I am able to do so many dashboards for big organizations, including the WHO, Africa CDC, Tony Blair Institute, and some Ministry of Health support. So if you want to really into Power BI, make sure you practice every day and have your own goal, what you want to achieve in Power BI, and practice. And whenever there is a difficulty, consult your colleagues and consult the people you know. And that is how you build yourself to be a Power BI expert. Saying that, just to use the time, let me share my screen so that we can go through the sections today. So let me know if you see my screen, and let me turn off the video for good communication and use the internet. Yeah, so you can text me on your chat if you see my screen, just to confirm. Okay, thank you very much, Princess. Thank you very much. Okay, so today, like it was mentioned in the introduction, we are going to look at data modeling fundamentals, just the basics. What is data modeling and why are we doing data modeling? And there is a common schema in Power BI for data modeling called star schema. What is that? Why is it called star? And we are going to practice building our model step by step together. Once we do that, because that is the fundamental to before we go to DAX or data analysis expression and doing any calculation, whenever we have different tables, we need to model them first. We need to create the relationship between the different tables. For those of you who work in database or maybe in Excel tables and that background, I think it is the same logic. It's a little bit different because of the Power BI nature. So once we are going to discuss about DAX, what DAX is, what are the syntax basics, and we are going to practice some of the functions. We are not going to look at and discuss and practice every Power BI DAX functions. There are many, even I don't know some of them. There are 250 plus DAX functions, if I'm not wrong, and we are not going to discuss every one of them, but we can discuss the basics. And then after that, we will have some exercise and we will summarize our training for today. So before you go to those exercises, I just want to confirm to each of you if you have the Power BI desktop. I know you installed it last week in the first week training. So if you have it, I want you, all of you, to open your Power BI desktop. I want to make the training as interactive as possible. So I don't want to just talk. I want you to do it with me together. We learn it together. So for that, I want you to open your Power BI desktop. And if you do that, we are going to have sample data for exercise for today. And I'm going to send you this link so that you can go to the tab and open open this training guide. And here at the end of the training guide, you'll find this sample data. I want you to download all these 4 different sample data so that we can use this for our analysis. So let me know when you open this guide and when you are able to download the different 4 tables or data that we are going to use today for exercise. So you can let me know on the chat if you are able to download the 4 of them. Then you can continue to the next step. So I'll give you 1 minute. Anyone able to download the 4 data tables? Just downloading only. Great. Thank you very much, Luke. Anybody else? Princess, thank you. Thank you. Lovable. Great. Odoo. Okay, good. So if you are able to download those tables for our exercise, we can start the first topic of today. So our first topic today is data modeling in Power BI. So what is data modeling and why do we need data modeling? So basically, in simple terms, data modeling is basically the process of structuring and organizing our tables or our data to create a relationship. Because when you are working in data analysis, it's not always straightforward of having just one Excel table or one table from any data source that you discussed last week in the first week training and start visualizing the data in Power BI. It's not like that every time. That only works only for very simple data analysis and visualization. Maybe if you have a coverage data of one Excel sheet, you may not need to do data modeling because there's just one table, everything is in one table. But in a real world scenario, sorry, who is asking, can someone share the document here? I got locked out. You locked out from the system or? Do you want the link again? I can paste it here for you. Yeah, sure. You can go to this link, and at the end of the tab, you will see sample data. So look, for your question, it was I was told it is 2 hours. So we have like 1 hour and 36 minutes from now. We will try to finish with that time, stick with that time. So that is why the reason we need data modeling, because like I said, it is not always straightforward and having one sheet and analyze everything. So in the real world, you might have 6, 7, 8, 9 tables from different sources, but those tables are interrelated. And you need to analyze data from the different tables. And in that case, it's not easy to sync data from one table to the other table if there is no relationship in the data modeling. So that is the reason why we need to have the data modeling process or creating the relationship between the different tables. So in database fundamental, I hope you are all aware about it. There is a relationship and there is a thing called primary key and foreign key. So each table will have, the main table will have the primary key and the foreign keys for the other tables. So it is the same concept here, creating the table relationship between the different tables based on their primary key and foreign key. So in Power BI, we mainly use 3 types of relationship: one-to-many relationship, many-to-one relationship, and many-to-many relationship. And we also use one-to-one relationship, actually. So what does one-to-many relationship? It means from one, for example, let's say we have a table called customer, and in that customer, we have the customer ID. So one customer may order different products from the other product table. So in that case, the relationship will be one customer linked with many products or in the product table. We will see it later in the Power BI once we upload our data. And when you talk about many-to-one relationship, many orders can be linked with one customer, the opposite of one-to-many relationship. So it is the same relationship with this one, but the interpretation is different. It starts with many orders to be linked with one customer, or multiple sale records connected to a single customer record. The many-to-many is, let's say, a simple example is a students and course. We have a Power BI course training today, and in these Power BI courses, we have different sessions. We had a session last week, we have session today, and we have session next week. Those are the many courses within Power BI training. And we have many participants in this training. So if you want to create a relationship between the courses and the students, it will be obviously many-to-many, because many students can be linked with the many different courses in this Power BI training. And one student may take many courses, and one course can be taken by many students. That's why the relationship is called many-to-many. I'm just giving a highlight. I know you are all aware about these relationships in the basic mathematics or basic database concept. But when it comes to Power BI, there is a concept called star schema design, where it is a gold standard Power BI data model. And it is called star because, as you see here in the diagram, we have the main table here in the middle. We call it fact table or center of the star. And all the other dependent tables here, customer table, calendar table, and the product tables are interrelated or mapped with the main fact table. As you can see, there is one-to-many relationship here, one-to-many relationship, one-to-many relationship with these different tables or the dimension tables. So if we have like another table, maybe a fourth table, it will be here. If there is another one, fifth table, it will be here. So it will create a kind of star schema design. That's why it is called star schema design. So because of this fact table in the center, we are able to now link all the four tables, and we can do our analysis simply by selecting a specific data or column from the specific table. So that is the importance of having this data modeling. The fact table, or the one in the center, is basically contains most of the columns or the data elements, the numeric measures. For example, the quantities, the amounts, the price, the cost, for our example, our data. And it also have the largest transaction or the largest rows or the events that we have in the tables because it is the main table. And when you come to the other dimension tables, they still contain different categorical data, but most of the time they are the extension or the description of these tables. For example, if we have a product here, this product table, it has product ID, product name, category, and cost. Maybe in the sales table, we may not find all these details about that product. We might have just the product ID here on the sales. So if you want to know the details of the product ID, we have to come to the product table. But the sales and the product table are linked or mapped or modeled with the product ID column. So these are mainly details of the specific data column from the main table. We'll see it in practice and it will be easy. So why are we doing the star schema? It is because it makes life easy to do analysis in Power BI. And it is so fast for queries and calculation. And it is easy to understand and maintain. And also it is so easy to create new dimensions without changing the table structure. Once we have here, we can create new columns without going back to the source data. We can create measures without changing any part of the table. But if you don't have this mapping between the different tables, it will be very difficult to create new measures or new calculations from the tables we have. So that's why we need this schema of mapping or the data modeling. So now let's do it in practice so it will be so easy. So if you open your Power BI, all of you, please follow me and then we do it together. So by the end of the training, we can create something like this. Once we do all the measures, we do the DAX and everything, we can have like a kind of dashboard like this. But to see these visuals, right now, with the data we have, we can't do all those things. All the cards you are seeing here and the charts you are seeing, the table you are seeing here, they are not available in the tables now. We have to do some calculation. We have to do some modeling in order to have this result. So for that, let's do it together. So if you already open your Power BI desktop, this is what you see, a blank space. And I know you did it last week, so I'm not going to repeat that. But let's import our data first. So Are you ready to import your data? Just show me thumbs up or text or whatever, so that I know that I'm not talking alone. Are you ready to import your data? Any reaction, thumbs up, text on the chat?
Yes, a lot of them are giving thumbs up.
Oh, okay, great.
Okay.
Thank you. So if that is the case, let's import our data. I know last week we did data importing. We go to get data. So this is where we connect our data from the source. So for me, I think I have CSCV. And here are those data elements that you guys downloaded from the link. So let's start from my main fact table, sales. So I click here, I open it. So I am expecting you also do the same so that we'll be on the same page. So I am seeing here my data, just a snapshot of the table. So it has sales ID, date, product ID, customer ID, quantity, unit price, and region. And it's fine. The first rows are here at the title of the column. So I think I am okay to just import them for now. But later on, we may need to do some arrangement. Maybe we may need to change the unit price to currency data type, and this to a number if it is not. But for now, I am okay to load. So let's load my data and see what I am seeing. Let me know if you have any difficulty of importing this table. Go back. Okay. So, oh, I had it already here. So let me remove this one so that it will not be duplicated. But for you, please import it. Then if you import it correctly, you have to see the table here on the left side of your, the right side of your Power BI under the data. So when I click here, I can see there is customer ID, date, product ID, and all the other columns. And then I will continue getting my data again because I need to import also customers. So if you are ahead of me, please continue importing all of them. So I'm okay for now. Let me load my data. So I have to see it here. Yes, customer is here. Fine. Let's continue the rest too. I have this one. Yeah, this is also fine. Let me add the other one, which is, I think, product. Product ID, yeah, that's perfect. Okay. Great, so let me rename this for me. For you, it will not show this. It shows, it will be like, I have to remove this one. Rename. And I have to remove this. Great. So by now, I hope all of you have these 4 elements. The 4 tables. So the next step is start modeling. So if you can see from your Power BI app, Right now, this body is, the visual body is blank because we don't have any data visualization done so far because we are still modeling our data. So if you see here, there is a report view, table view. I can come and see my tables here. So when you select the table, you will see the details, all the rows of the table here for each of them, like this. So the third one is the model view. This is what we are interested for now. So if I click on model view, right now, I didn't do anything, but Power BI by itself did the modeling. It might be right, it might be wrong. So I have to check it. But if there was no any modeling, I can delete the modeling actually and do it myself. Or I can also edit. Let me delete this for now. But because of the development nowadays, Power BI will do the modeling, but that doesn't mean it is always right. We have to check it ourselves. So if you remember when we discussed earlier, the sales table is our fact table, which is in the middle. Now we have 3 other dimensional tables. We can do a modeling now. So for example, let's connect the customer ID from sales table to the customers table. So here we have this customer ID, right? And under customers table, we have also customer ID. So these are the 2 columns which can connect these 2 tables. So once we connect these 2, that means these 2 tables are connected and ready for analysis. So what you are going to do directly is just drag, click on here, long press, or what you call it, press, and drag it to customer ID here. When you click that, a new window or new relationship will pop up. So the new relationship is from table sales to table customers. So here, this is sales. Under sales, we will have customer ID, but it might not be unique because one customer, like we discussed earlier, for example, customer 1001 might have so many purchases or sales. So that means the relationship will be many sales to one customer. That's why by default at cardinality, it brings many to one. But if you want to change, if you think this is not correct, it should be 1 to 1, you can change it to 1 to 1. You can change it 1 to many or many to many. But for our scenario right now, there will be one customer ID. The customer IDs are unique. So that means there will be only one customer ID, but that customer might have so many other purchases or sales. So it should be, it will be many from sales to 1 to customers. So if I save it, now as you can see, it is created and 1 is showing this is 1 and this star, it means it is many. So it is many to 1 relationship. If that is correct, and if you are all on the same page, let's do another one together. Again, where we need to connect our product with our sales. So the column that will help us to connect the product with the sales is product ID, because here is the primary ID, the primary key, product ID. So we can connect sales with product ID. So the same thing, we drag product ID to product ID of under the product. So can you do that? And let me know if you do that and if you are able to create the connection. The same thing, it will bring that pop-up message for you to check. So I drag this, bring it here, pop-up will come. So this is a product ID. Each product, like Laptop Pro 15, has its own product ID. Ultrabook, it has its own product ID. But one product can be sold to many, might have too many sales. Maybe Laptop Pro 50 might have, right now it says 2 quantity. One also is 3, that means there might be many. So the relationship is the same, many to one again. So I save it. Now the relationship is created here. Now we have the calendar. Okay. For calendar, as you can see, the dates column is our common ID or common column, which will help us to connect this table with this table. So the same thing, I'll drag this and connect it. Right now, if you see, the relationship is changed. It is not many to one because the dates are one. One date will have another one date because we will not have December 7, 2025 by tomorrow. It will be just only 2 days, 1 day. That's why the relationship by itself automatically comes to 1 to 1. But if you think this is not right, it should be many to one, there is option to change, but that will be wrong. So right now it is just 1 to 1. We are going to save it. Now all the 3 relationships or modelings are created for our exercise. So let me know all of us have this. Otherwise, if you have any problem, I can go through it again. So any thumbs up? Okay. Are you good? All of us? Let me know in the chat if you are okay. Great. Okay, there is a question from Adwali. Is that a question or? Okay. If not, let us continue. So,
Michael,
yes,
if
sir.
you ask a question, we can allow Adewale to speak. He has been asked to unmute. There's someone else in the Alex lost you in the third model. You could delete the relationship and then show him or her how to connect for the third model again. The date to date, yeah. Thank you.
Okay.
All right, so thank you, sir, for the explanations so far. While I try to understand the many to one and all, can you just go over the explanation again? I was flowing, but I think I lost the process along the way.
Sure, right. No problem. Okay, so let me start.
Thank you so much, sir.
Sure. Let me start from the sales and the customers tables. So what I wanted is to connect my sales table with the customer table because, for example, if you can see here, there is a cell and there is product here. Let's say this product is laptop and it is sold maybe 20 or 40 laptops. But I just want to know which countries are this or which city. Right now in this table, I don't have that information. The detailed information about this product is here under the customers. So if I want to know the details where and who the customer name, I have to connect this table with this table. That is the reason why we need the modeling. So that when you talk about sale of the laptop, I will have all the details. I will have the region, the quantity, the city, the country, who that customer is. So to do that, what I did, let me delete this again. Let me delete this. Now this table is not connected, as you can see. If I do analysis, I will not have this information in my analysis under sales because this is now disconnected. So what I want to do is to connect this table with this one. To connect two different tables, we need to have a common column, which is available in both tables with the same information. Otherwise, we will not be able to connect the two tables. That's why we call earlier in the basic database concept, there is a concept called primary key and foreign key. The primary key is the main key in that table, and the foreign key is the one which helps us to connect this table with this table. Right now for sales, as you can see, there is sales ID, which is the primary key for this one, for sales. And customer ID is the primary key for customers. But we can't connect sale ID with customer ID because these two are different information. So the common ID we have, or the common column we have, is customer ID here. We have customer ID here, we have customer ID here. So this customer ID is a primary key for this one and for the other table. So if I want to connect the two, what I do is just drag this, come to customer table. When I do that, this table will pop up. So here, it is telling me there is a new relationship that we are creating. The relationship is from table sales to table customers. So under sales, we have the customer ID, the different customers who had a transaction on the sale. But under customer, we have the list of our customers. For example, customer 1001 is John Smith from New York, USA. But John might have, let's say, 5 different sales transactions in this table. That means you will find 1001 5 times in this table. And maybe 1002 Sarah might have 3 transactions in this table. That means you will see 1002 3 times in this table. But under customer, each person or each customer have a unique ID. 1001 is unique only for John Smith. You will not find another person with the same ID. That means here we have only one entity or one person under the customer, which can be connected to many transactions under the sales table, because John might buy laptop, clothes, car, or whatever we have in the sales data. So if John has a transaction of 4 or 5 different sales, when you connect these two tables, it will be many items or many sales with one customer. So that's why the cardinality here is showing many to 1. If I put it 1 to 1, that means here under sales, there should be only, or it should be allowed only 1 sale for 1 person. If that is the case, it would be 1 to 1. But in this scenario, 1 customer might have 1 and more than 1 transaction. That's why the relationship is called many to 1. But when you come to the calendar here, so by the way, here, once you created the modeling or the relationship, you can edit your relationship if you think there is some issue. To do that, you just double click on the line here. When you double click on the line, it will open the relationship and you can change it here. Or you can even change the column, by the way. If I want to connect product ID with day name, I can do it. But as you can see, this relationship has cardinally many to many. And basically, it's not right because product ID and day name are not the same information. So we can't connect these two. That's why we have to select the right column, date with date. Now we have the same information in both tables. But right now, in this table, the dates in this table and in this table are only one. There will be only one day in both tables. Thursday, January 2025 is the same information here in Thursday, January 2025. We will not have another Thursday, January 2025 because dates are like specific. Today is just today. You will not have a different today. Like your birth date is specific. You can't change it. And there is no another same day of that date of your birthday. That's why the relationship here is just one-to-one. It's specific. Just today is linked with today. Yesterday will be linked with yesterday. You might have hundreds of purchases yesterday or sales, but the day is the same. If you buy 5 items today, the date is still today. Whether it is 5 items, whether it is 100 items or 1 item. That's why the relationship is one-to-one. I hope that makes it clear for you. So if you do that, I hope all of you have this relationship. With that, it means we are done with our first topic. Let me go back to here. So now we have imported our tables. We have modeled or created the relationship between sales table and customer ID, sales and product ID, and sales and calendar. So, but always, like I said earlier, Power BI nowadays will create the modeling automatically, but you have to check. We have to confirm if that is the right cardinality used. That means the relationship, whether it is many-to-many, one-to-one, or whatever. And we have to verify. And in this concept, there is a single direction and both direction relationship. Let me go back here. Here, if you see the cross-filter direction has a single and both option. What does it mean? When you click single, it means, let me go back to, so when it say single, it means the filters flow from the dimension to the fact, from this table to here. So when I click name of someone, it will filter the data here. But if I put it both, it will filter in both tables. So most of the time it is recommended to verify this, but there is no hard and fast rule, but both directions is some of the time it will create some ambiguity in the tables, and unless there is a specific need to put both direction, it is recommended to put single direction. So I think we are done this one already. If there is no question, we can continue to our DAX so that we can use our time. We have 1 hour from now. So any question? Okay, we will do some exercise later, so it will be also more clear. So let's go to the DAX. So what is DAX? So DAX is basically a simple abbreviation for data analysis expressions. So data analysis expressions are basically a formula language in Power BI. If you remember, and if you have the experience working in Excel, there is a thing called formula in Excel. Let me open an Excel just to show you. So here you see, if you remember here, there is this formula functions of Excel. So this is a formula. And it is the same concept in Power BI. It is the formula language used in Power BI so that you can create a calculated column from the tables we have. From the information we have, we can create new information, new column. We can add 1, 2, 3, 4 additional columns on our table from the existing data and from the existing columns we have. And you can create a new measures or an aggregate or a summary. You can even create a new table using DAX. So basically it is a formula language for Power BI. That is the simplest definition of DAX. So it is created by Microsoft specifically to work with relational data models that we did earlier, so that we can use different tables and synthesize information from the different tables, and also to do some calculations across filter data. And there are some time-based analysis which needs really the formula or the DAX to come up with those informations that need a kind of somehow from a complicated calculations, time intelligence in DAX. So basically, why do we need DAX is that unlike Excel, DAX understands the filter context. So when you filter data, for example, by region from one of our table, the measures that we created with DAX automatically calculate for that specific region without rewriting formula for the other region. So once you put that measure using a DAX formula, it automatically filter, and DAX or Power BI will know where to analyze and which data specifically to analyze. And it is a kind of prompt or a kind of instruction for Power BI. So it also will help us seamlessly with table relationships that we created earlier. It will pick data from the different tables. If you have a, let's say, a measure which needs data from the two tables, it will pick data elements from the two tables, connect it, and analyze it. If it needs to be multiplied or if it needs to be divided, Power BI will automatically do that based on the DAX formula. And the good thing is that formula will work with millions of rows. So sometimes you might have a very, very big data which have millions of rows. So once you put the formula, DAX will manage the rest. That is the beauty of having DAX. And it's also have reusable business logic. Once you created a measure, you can use it everywhere. If you created a measure in the sales table, you can use that measure everywhere without copying the formula again. We'll do it in practice so that it will be easy. So just comparing with Excel formula, for example, the context for Excel, it is cell-based. You do the calculation just in this cell. Specifically, for example, if I want to multiply this cell with this one, I'll do it just specifically in this cell. But for DAX, it is column and also filter context. That means it will consider all the table within that schema. Then it will make it easy without you doing it, dragging down to all the cells or all the rows. It will automatically do it everything. Because in Excel, if I want to have the same information for the rest of this, I have to drag or I have to click here so that it will make me, give me the result. But for DAX, once you do the formula, you put the formula, it will cover everything. It will manage by itself. And the calculation, like I said, it is the Excel is by row. This is the entire column or the entire table. Dynamicity, Excel is limited, but here it has a built-in and very powerful, and it is good for big data than the Excel. But the concept somehow is the same with Excel formula, but like I said, it will consider the whole column and it will filter by itself. You don't need to drag, or you don't need to copy formula whenever you have a new analysis. You just use the same DAX, or the same measure which is already created. So in DAX, we have a syntax, or I don't know what you call it, but it is just the full formula, but we call it DAX syntax. So for example, here if you can see, measure name is equals to function of table and the column within that table. So this whole text, or this whole formula, is called syntax. But each of them have their own representation, these components. For example, the measure name here is the name of your calculation. What are you calculating? For example, if it is total sale, so I can write total sale equals, then function will be now sum, because I am summing the total sale. So total sale equals sum of, the table is sales, and the column is sales, maybe if there is a column called sales. So the measure name is the name of what you are calculating. And this one is called operator. Right now it is equal, it might be plus, it might be minus. Because we are going to use some formulas here, we may use plus, minus, multiplication, all those operators. So this is called operator. And the function is the main part of DAX, and it is inbuilt function like sum, average, and there are many, you will see them later. The table is here. We already have a table. This is our table, and these are our columns within the table. So for example, this is, I think, the sale table. So under sale table, we have product ID, customer ID, quantity, unit price. All these are region, and all these are the columns under the table. So these are the main components of a DAX syntax. So whenever you want to do any DAX, we need to consider these components. If one of the components is missing from this, the DAX will not work. And we need to make sure we are using the right operator for that specific DAX. We need to make sure we are using the right function. If we are dividing something, we can't use sum. If you want to have, for example, a total sale or a total count, we can't use average. So we have to make sure we are using the right function. If that is the case, there is a thing called DAX operators. These are the common operators that we are using in DAX. I'm not going to explain all of them because these are common things that we know: plus, minus, multiplication, division, concatenation, equal to, and this one is maybe the new one, which means not equal to the opposite of equal to in DAX. This is what we are using to check if two values are different. And here, the two double ends are called AND, and it only works when both of them are true. For example, if we want to calculate something from our table where the amount is greater than 100 and the region is north, it will only, and if we use this operator, it will filter the data which have an amount of greater than 100 and specifically under the region north. The other opposite of it is OR, and we are using this operator. If I say region equals north or region is equals to south, it will calculate or return the result is either of the two is true. If there is south in this data, it will calculate for us. If there is north, it will calculate. If they are both true, still it will calculate. It only needs to be one of them to be true. But here, the end, both of them should be true. That is the only difference. And one of the big things we need to consider in DAX is parentheses. So these are very critical in DAX because these are used to contain function argument. For example, if we want to do sum, I will say sum of what? Then I have to have the parentheses. Sum the amount. From where? From sales table. So to separate all those things, we need to use parentheses. So if I remove this one parenthesis, the DAX will not work. If I remove this internal parenthesis, again, it will not work. So parentheses are very critical in DAX. And it will also help us to control the order of the operation. The basic mathematics rule called BODMAS, for example, right now there is sales of price with plus tax times the quantity. So which one should the syntax or the DAX do first? The brackets or the parentheses will determine. Right now, because of these two parentheses, DAX will calculate this first, then it will multiply it with the quantity. So these are also very critical in DAX. And the other concept we have in DAX and that we are going to work today is calculated column and measure. Both of them can be created using DAX. And the reason why we are using DAX is actually to create new measures from the table we have, from the data we have, and to create a calculated column from the data we have. So both of them will result or give us a new insight or a new data from the data we have, from the existing data. But they have a little bit differences. But we are going to use both of them for different purposes, and both of them need to use DAX or that Power BI formula simply. So a calculated column is basically a new column you add to your table using a DAX formula. And for this, the new column only calculates each row. So we are not going to have a calculation of the whole table. It will not take data from the whole table. It will take one row data to calculate that specific data. So that we will have one new column for each table. For example, let's say we have age, or let's say we have name. So if I come to my Power BI, let me show you this. And let me go to customers. And now customer name it has both first name and last name. So let's say we have first name here and last name here. And we want to create a combination of the customer name. If that is the case, for example, to merge John and Smith from different columns in one column, we have to create a new column because this row specifically will give us a result here called John Smith. So let's create one maybe. Okay, we'll do it later as exercise. We'll merge city and country in one column here. If that is the case, we are doing calculated column which calculates data from city and country and give us the address, the full address of city and country. So in that case, that means it will calculate this row, give me result here. This row, give me Los Angeles and USA. So that is calculated field. But when you come to measure, a measure is a calculation that evaluates based on the filter context, or it will compute the whole thing, the whole table. It will give me a dynamic calculated field, which automatically changes the value whenever something is changed in the table. So mostly we use it for aggregated measures. So for example, from this table again, if I come back here to my tables and let me go to sales. Let's say we have a unit price for each product ID here. If I want to know the average price of the whole product here, calculated column will not help me, because calculated column will only give me information about this row. So the average price for that specific row for this one will be the same, 299. But what I wanted is the average price of all these items. They have different unit price, but I just want to know how much is the average unit price for all the items. If that is the case, measure is the best way which help us to get the average unit price of all the items, because it will consider all the items and it will give us a value. We don't need to put it here as a column, because it is the average of everything. So because of that, the value that we are calculating as a measure will not be stored in our table. We will not see it in our table, because it is like the whole sum, or it is calculating as an aggregated findings or aggregated values. But for calculated column, when you created a calculated column, you will find it in your table here. There will be a new column here. So whenever you created a new column, calculated column, it will add it here. So it will be saved here. But when you change a value here, of course, it will change the value. But that for that specific row. So that is the main difference between calculated column and measure, but both of them use DAX to create and analyze data. So let's do some exercise so that it will be more clear for all of us. So the first DAX that we are going to use is to create our calculated column. So we want to create total amount from the sales table. So if you copy this formula from this sheet, go back to your Power BI. So this is my table, the 4 tables. What I want to do right now is to create a calculated field, or a calculated column, in the sales table. So to do that, I just right click here. When I right click on it, you'll see new measure and new column. So for now, what I wanted is to create new column, which will be stored and added to the table. So let me click new column. When I click new column, the same as like we saw in the Excel sheet, it will bring a formula pane here. So it will give it like a name of column, but I don't want to use the name column. What I wanted is a name of column called total amount. So what is total amount for me in this formula, in this table, is the quantity times the unit price. So I want to know for each row or each product that we have in this sales amount, what will be the total value of that price. If I sell all the quantity of that specific item I have, how much money will be at the end of that day. So I want to multiply this quantity with the unit price. So that's why in that case, I have to write sales table. As you can see here, whenever you type the table, it will bring all the columns you have in that table, as you can see here. What I wanted now is to multiply the sales quantity. Means right now, this is my, if you remember earlier, we said the DAX has components, and this is the total amount is now my measure name, and the equal is my operator, and sales table column quantity is now my table and column. And I'm going to multiply this so that I know I have the value that I wanted. And I'm multiplying this with the unit price. Again, it is in the same table. So I have to mention where. So it is again the sales table, but now it is unit price column, this one. So now I am done with my first calculated column. On the right side here, you can see to commit or to cancel. If you think it is right, you commit. If you think it is wrong, you cancel it. But for me, for now, I think it is right. If it's some error, it will tell you, no, this DAX has an error. So if you come back here on my sales table, you can see total amount here. It is created. Let me open the table and see. You see, there is a total amount column, and it multiplied this quantity with this unit price and giving me the total value or the total amount of money each product had. So if I created another column, again, it will continue, it will store it here. And it is very simple. If you click on it and if you want to edit it, you can still edit it. And I was trying to explain the importance of parentheses. Let me remove this parenthesis like this. You see, it's saying the following syntax error occurred during parsing: invalid token, line 1, offset 24, unit price. You see, it is even telling me where the issue is. So there is an issue here. That means I need to bring my parentheses back. Now it will correct it. You see, it is gone. So this is very important. So now we have created the total amounts calculated column. So the result, as we saw earlier, there is a new column called total amount, and it is also saved in our table. Let's create our first measure now. But before I continue to our first measure, are we together? Just show me a thumbs up or yes on the chat so that I know we are all together. Great. From participants, anyone? Are we together? Okay, thank you, Alex. Thank you. Okay. So measure, the procedure is the same, like calculated column. The difference is, like I said, the purpose and how they works. So let's create now a total sales measure. So right now, when I do the total sales measure, it is not giving me the total sales by row. It is giving me the total sales of everything in that table. So if you remember, let me go back again to the table. So this is the total amount for each row or each product. Where is it? Okay, yeah, this one. So for product ID 101, this is the total amount. For product ID 102, this is the total amount. But if I want to know the total sale of everything, I have to create a measure, not a calculated column. Because if I created a calculated column here, it will be the same result for every row. It will give me the sum of all these rows as a total sale of this row, which is wrong. So that's why we use calculated column when we want to know the information for each row. It will automatically update if I change the value of this, it will automatically update the value of this, but it will only consider each row. But when you come to a calculated column, measure will have an aggregate of all. Let's do one and see the difference. So what I want to do right now is total sales. So here, as you can see, there is no total sale column. And that means I don't have any information how much the total sale is. So in that case, what I can do, I right click, the same thing I did. Instead of new column now, I will click new measures. The same thing will come. Earlier it was saying column, now it says measure because I selected measure. But I want to have my own name here. So the name I am going to use is, let's say, total sales. So this is my measurement. This is my operator. So the total sales for me is now I need to have a function. I'm going to add everything. So that means I need to have the sum function here. When I write sum in small letter, it will bring the function for me. I will select sum. As you can see, automatically, it opened the parentheses because the next step when you use the function, will have parentheses to separate the different logics and also to give the DAX which one to perform first. But right now, the sum that I'm going to do is on the sales table. It will bring calendar, no, customers, no, products, no. My calculation or my total sale that I want to do is under the sales table. So these are the columns under the sales table. And my total sale is the sum of the total amount because I'm calculating the total sales of all the products in that table. So we created the total amount as a calculated field for each row. Now we are doing the aggregate of all the total amount. So if I click here, as you can see, now I can commit or I can cancel. But there is an issue. Who can tell me what is left here to finalize this? What is left? Anyone on the chat, in the chat box? What is left to commit? Yes, thank you, Joel. Parenthesis. I have to close this parenthesis here. I open a parenthesis here, so I have to close it. Great. Now, let me commit it and see. Okay, great. So if you see on the right side here, there is total sales, the same as total amount. But let's see if this total sales is in my table. Let me go back to the table view here. And this is the sales table. I select sales table. There is no total sale column here because I created a measure, an aggregate, not a row by row value of a calculated column in my table. That's why you are not seeing it here. And if you remember when you talk about calculated column and measure, I say the calculated column will be stored in a table and it will be available, but it will update the value whenever this is changing. But for measure, it will not be saved, or it will not be stored in the table as a column. It is an aggregate value of each. Whenever you change something here, the value will change, but it's not here. It will be in our calculation or in our visuals later. Great. With that, if we create our first calculated column and our first measure, let me give you the chance to create your first calculations. So let me add the card of the visual to see the total sales so that we see how it works. Now, we have this value of total sales. I want to know how much is the total sale. So let me add just a card here from the visual, and on the field here, I select total sale. So this is the amount of the total sale. This is the amount of the total sale. This is how the visualization starts. But to come up with this value, if you go to your table and see the sale or the quantity or the price, the unit price, you can't get this value. So to get this value, we did two steps. One, first we created the total amount for each product, that is the calculated column. Once we have the total amount for each row, we did the total sale aggregation as a measure. Now, the total sale is not stored in our table, but the value is here. It is available because it is created as a syntax. So wherever in this dashboard you have, if you want to use the value of total sales, you can use it anytime, anywhere. That is the beauty. You did one and you use it every time or anywhere. Great. So we have created this, and it is telling me that to add a table visual with product name and total sale. Okay, so let me go back to here and create a table. Oh, sorry. I have to unselect this, and then let me create a table here. So in this table, it is telling me to put product ID to know the total of each total sale by product, and total sale. Okay. So you see, this is the total sale for everything, 124,117.50. But this is the total sale for each product ID. So product ID 101 has a total sale of this, product ID of 102 has a total sale of this, but the total sale for everything is this. So with this, you can show for your people, mostly we use card to see the general value or the summary. And for people who want to know the specifics, they can come and check here the specifics. So if I select 101 specifically, you see it is filtering it. The total sale for 101 is 780. Yeah. So with this, it will help us to create our visuals easily, either a card, a table, a bar chart, whatever you want. Okay, I want you to practice this one, to count the total transactions or the rows we have under the sales, because if I go to my table, let me go to the table view and see, as you can see, there are like 100 transactions under the sales. That means we have a sales 100 times, but it might be the same item, like 101 is here, 101 is here, 101 is here, one product, but it is sold many times at different dates. So, and different quantity actually. So we want to know this formula or this syntax, the transaction count, is counting the total number of rows in the sales table. So I want you to do this three. Copy the formula and see what you are seeing in your Power BI. I'm doing it for myself, and you do for yourself. And let me know if you are on the same page. Just copy the formula for now so that you can practice. So I will be on mute for the next 2 minutes so that you can do your 3 measures. I'll give you 2 minutes. Okay, we are back. So for me, I have created my unique customers measure. I have created the total transaction count, and I have created the average sale. Do I created my average sale? Where are you? Total sale, total amount. I think I have not created my average sale. So I have to create my average sale here. Average of sales, total amount. I have to close my parentheses. Yeah. Now I can put all this on my visuals. For example, I can see the average sale. This is the average sale of everything here. And I can also visual the transaction count. So the total transaction counts are 100. And I can also put how many unique customers we have. Okay, we have 10 unique customers. So all these 100 transactions has happened between these 10 unique customers. So that means in average, one customer had a sale transaction of 10 to come up with this 100 transaction count. Okay, so pulse check. Who did all this? Who did all this? Who is at this step? Anyone lagging behind? Anyone ahead? Please let me know in the chat box so that we can continue to the next. I'm not seeing any. Okay, look, thank you. Anyone who did all this? Who created the transaction count, the unique customer, the average sale, the total sale? Just to check, how many of you are using a laptop? Thank you, Alex. If you don't have a laptop, if you are using your mobile phone, I don't think it will be a little bit difficult to come up with these calculations. It is not easy unless you guys are so expert on mobile coding. But for those of you with laptop, it's not complicated. Thank you, Alex. Thank you, Kiro. Okay, great. So that means we can continue to the next step. So our next, I think we are done with this one. Like I said, these are just examples from the data we have. So after the training, with your own schedule, try to practice creating different measures, creating different calculated columns so that you master the whole process. So what are the common DAX functions? The common DAX functions, like I said, there are many DAX functions that we are using for different purposes depending on our area of expertise, depending on the sectors that we are working on in the industry. If you are in business, you may need to use many of them. If you are only doing a very simple visuals, you may not need to use everything. But we have a DAX functions which do some aggregation, such as the sum function, the count rows function, the one we did earlier, the sum is the one we did earlier, the destiny count, average. These are common functions that we know in Excel. They have the same purpose here in the Power BI. And we have a filter, context and filter table functions like calculate and filter. We are going to see them, both of them today. And we have a time intelligence functions which calculate data from year to year, month to month, year to date, month to date, and comparing this month from the previous month, this year data from the previous performance, kind of thing. We have also a relationship functions like related and not related. But there are many. These are just examples because we can't discuss all of them in this 2-hour training. Just to give you a highlight, there are many. So, but the good thing, all these functions are built in using Power BI, and you can click in one of the function and practice and learn by yourself. Just for today, we want to emphasize on calculate function and filter function so that we understand, because these are common functions which do so many beautiful things. So the calculate function basically evaluates the expression in a modified filter context. That means it will do, like, for example, if you want to do the total sales, we just did some of the total amount. But when you use the calculate function, it will calculate for us the total sale for a specific category within a specific country, if you want, within a specific date, if you want. So it will use that filter expression or the context of filter and modified the totals, the values. Instead of putting the sum total or the whole value, it will filter by context based on the expression that we are going to give to the Power BI. So for example, here in our data, there is electronic sales. So let's say the company wants to know the situation of electronic sales. So they just want to know the total sales for the total account, the total electronics. So earlier, if you remember, when you do the measure, we said total sales equals the sum of total amount within the sales table. So this is the crude value, which give us the total sales of everything. But when it comes to specifically want to know electronic sales, for example, we can use this formula. Electronic sales equals calculate total sales, this one, but where the category of the sale from the product table is electronics. Now, if you remember when you do the modeling at the beginning of our discussion today, the reason we do the modeling or creating the relationship between the sales table and the product table was to have the full information of that product both from the sales table and the product table by linking the two tables. Right now in this formula, if you see this expression, total sales, it is available in some table, in the sales table. But the product category is not available in the sales table. Let's go to our table and see it. So this is the sales table. In this sales table, we have total sales that we created earlier using measures. And this total sales considers this total amount, the sum of this total amount. And this total amount considers this unit price and this quantity. But we don't know product ID 101. We don't even know what product ID 101 is right now because there is no information here. But if you go to our product table here, product ID 101 is basically electronics, and it is specifically laptop Pro 15. Product ID 102 is still electronics, and it is Ultrabook X1. So if I want to know the total sales of electronics only separately without considering the accessories, the sales table, this table will not tell me because there is no information here whether this is electronics, this is accessories. What determines whether this is accessories or electronics is this product ID. And this product ID is just ID, to not give me the name. So because I have this schema or this modeling that connects my product ID with this product ID on the sales table, that means the product name, the retail price, the cost, and the category are included in this table indirectly by this relationship. Great. So in that case, if I come back here, and if I want to create electronic sales, total sales of electronic sales, I copy this formula just for the sake of time. And let's say I create new measure. So my new measure is electronic sales, which calculates the total sales, this one, but there is a condition. The condition is product category should be electronics. So in this case, DAX will take the data of total sales from the sales table here, and it will take the product category information from this table. This table, this column, category, right? So I commit it. Now, if you see here, there is electronic sales. Great, let me add my card and see if it gives me the value of electronic sales. Great. Yeah, that is it. So this is the value of electronic sales. So by doing that, this calculate function will help me to do specific calculations from the totals. It will filter, it will context the modified filter context. Okay. Now I want to know the total sales again in North region. The same thing in my sales table here, I don't have region. I mean, I have region here, but I want to know the sales of North only. Right now, these total sales give me the sales of all the regions, but I want to know only for North. You can do this by adding some slicers here, for example. If I add a slicer, I can filter that value by slicer. But for big data, it may not be always true. Right now, if I do this and if I select North, you see it will filter everything for me. These are the transactions, these are unique customers in North, these are the total sales, these are the electronic sales. It will give me that. But in big data, you may need to do it with DAX, not slice. So I want you to practice with me. Let's do this together. I want you to do it. Open your Power BI, copy this value, go to sales table, create new measure, and paste it. Now I have the North cell here. I can create my card. Oh, sorry. I can create my card here and select where is North cell. Yeah, this is the North cell. So the calculate field, the calculate function will help us to do this. So by doing this, DAX will restrict the calculation to cells only happening in North region. We have the filter function again. When you do filter returns for us a table of rows that meets that condition, specific condition. So for example, I want to know the high value cells. That means cells which have greater than 1,000 cells. So if I want to do that, let me copy this again, go back to my Power BI. If you see here, our measures are now becoming many than the initial columns we have. So with few data, we can do so many calculations. So let me paste this. So this high value cells is calculate from the total cells where, this is the filter function comes, where the cells within that sales table, the total amount is greater than 1,000. So I am telling DAX, Power BI, calculates the total sales, but with a condition. What is that condition? Filter the cells from the sales table, from this table, where this total amount is greater than 1,000. Now, let me create it. High value cells is created. So if I want to have my card and put it in a table, where is high value? High value. These are the high value total sales. And simply it will filter for me only the high values where the sales are greater than 1,000. Let me go back. So this only give me the rows that have a cells where the total amount is greater than 1,000. So let's put it in table so that it will be more clear. So let me create table. And where is my product? Products. Yeah. So these are the only products which have high value sales, which is greater than 1,000 USD. Okay. By the way, I thought you discussed this so that I just skipped it. Right now, this is showing me just number, but this column was supposed to be a currency, either dollar or euro or birr or naira or whatever. But right now, it's not showing anything because we didn't do transforming the data from just number to a currency. So who can tell me what to do to change this to currency? Anyone? So if you click here, for example, on the total sales, here you can see it format is general. So I can change this to currency. You see, it automatically changes this to dollar. The same thing, let me come to this high value and I change it to currency. So you see it's automatically changing it to dollar. Yeah. So the calculate and filter functions in combination will give us this kind of data calculation and analysis for us to make things easy, to make life easy. The next thing we are going to see is time intelligence. We are going to do some practice, don't worry.
Yeah. So why you want to get your power pack to, I can see you need to do something with your computer, right? Michael?
Yes?
Yeah, I think you need to charge your computer to complete.
Yeah, I did.
Yeah.
I did.
Yeah. Are you doing it already?
Yeah, it was near with me, so yeah, it's fine.
I wanted to do one or two things before you go to the next module.
Yeah, please.
So you are moving to the next module. Let's see the next module.
Okay.
Thank you, sir.
So, okay, great. So the next module is the extension part of this module. That's the same module. I just want to make them short. But these are like functions for aggregation, counting, distance count. We did it already. When there is no blank in the row. And this is switch function where if you want to know, like, for example, those with total sales of 50,000 to be platinum, and this one's to be called gold. It is like a kind of renaming or categorizing. And we have and or not functions. I'm not going through all of them because of time. But what we can do, since we have this guide, you can go through it with your own pace. And if there is any issue you need to consult, you can text me anytime to my LinkedIn. I'm available to support. But these are just very simple common functions. If you follow the formulas here, it will give you a good visuals, but you have to practice. Obviously, you can't remember everything in one day, in 2 hours. You have to practice and you have to do some analysis or some, if there is any challenge, we are still available. Me, Benga, we are available for any support. So there is function here, there are exercises here, and you have answers here also for each of the exercises we have. you'll find the answers here. You do it first, don't copy from the answer. Do it first, then come back and check from the answers. If you have any challenge still, like I said, please let me know. So these are some of the additional basic measures you can practice. I think I don't need to go through them again. And just to do a little bit here, because of time. So this is the sum function, aggregation function, you know it always, but the only difference with sum and sum x is this one. The sum x iterates your calculation over a table and evaluate an expression for each row. That is the only difference. Otherwise, you know sum function, average, you know average function, minimum and the maximum. These are the same concept that we have in Excel. If you do Excel, it is the same. You can calculate minimum self of the total amount and the maximum sales of the total amount. Count, it is the same concept we have in Excel, count of amounts. For example, if you want to know just to count the total amount, how many counts or how many cells we have, you can do count. And if you want to count non-blank values, maybe in the row, if there is any blank value, and if you want to avoid that, you can use count A instead of count. And like we did earlier, if you want to count the whole rows, you can use count rows. Distinct count, we did it already earlier. But if you want to avoid the blank rows or the blank data from the column that you are counting, you can use distinct count, not blank, sorry. And the if switch is a logical function. You will give it some logic so that it will categorize your data. For example, here you want to know, create a performance tier. For those who sells more than 50,000, you want to call them platinum tier. For those selling more than 25,000, you want some of gold. In that case, you use the switch function. So switch, when it is true, when the total sales is 50,000, call it platinum. You put it in quotation so that it knows it is a text. Total sales, 25,000, say it gold, 10,000 silver. Otherwise, if they're, that means below 10,000, just call them bronze. Done. Now, in that case, and if you want to display this in bar chart, how many platinum, how many gold, how many silver, it will bring the data for you. It will do everything for you. And I think the content is huge and the time is very short. I think we are done 2 minutes out of our schedule. But what I recommend is, like I said, the formulas are here. The data is with you. If I do the same thing, it will be the same. Just copy this, paste it to your Power BI, see the result, and try another one. For example, I did here month to date, year to date, and quarter to date. And you can change the dates and try a new exercise. Like, for example, earlier I was saying when I talk about the switch function, I was using platinum, gold, silver, and bronze for the high performance. Maybe you want to know the high tier customers. For example, the customer who had many transactions with you, your platinum customer or your gold customer. You want to reward them and you want to categorize them. So in that case, you may use switch function so that you change this part. Instead of total sales, now on this value, we may need to change it to customer. So replace the columns or the data elements and try to create your own thing here using these examples. So with that, you will practice and you will be excelling DAX. And like I said, mastering DAX is not a one-time thing. It's not a one-week training or doing 3-4 examples. You have to do it many times to excel so that you will master it. But once you've done it, it will be so easy for you. So basically today we were trying to do some data modeling. We try to understand what the star schema is, and we try to see the different types of relationship in the cardinals, and we were trying to see the calculated columns, the purpose and how to do it, the measures and how to do it, and the filter context on the calculated filter function. And we just highlight the essential functions of DAX, that the common ones, these are not the only ones. Like I said, there are more than 250 plus DAX functions. We don't need to discuss or know everything, but we have to know the basics and the essential ones that we are using on our day-to-day activity. So just best practice to recap. Build measures incrementally. That means, like I said, start with simple measures, like maybe average, sum, kind of thing. And then later on, you can come to the complex ones like the calculate, the filter, the all except, the time intelligence analysis. But start from simples and you develop every day to the big one. And most of the time when you do divide function in DAX, because of the common syntax that you're using in Excel, instead of using that slash or backslash, use divide as a function, because that backslash sometimes confuse Power BI with other operator. So it is advisable to use divide instead of that backslash. And when you do measures, if you remember in Power BI, when I do these things, for example, this north cell, I tried it with a measure and it gave me a value. But I might want to confirm whether this value is really the right result or it's just giving me a number out of a blue. So in that case, it's always good to verify with other ways. So if you remember earlier, I was saying I can do a slicer and add the region as a slicer so that I know the value for north. So as you can see, the total set for north is 19.35 thousand. So it is the same with what I have this. That means my measure formula here is correct. So that way, sometimes you may need to verify your calculated columns or your measures so that you have the right result. So like I tried to say earlier, practice with the sample data provided and using the different codes we have in this guide. These are just an example formulas and practice data, but you can extend this to your own data, big data, if you have a big data, and use the formulas so that you will have a more advanced level of understanding of DAX. And Microsoft has a good DAX documentation. If you have time and if you want to go through it, you can go and read that documentation. It has a lot of information, very important step-by-step information. You can also read from there. I brought all those things from there actually. And if you have a community around you, join a Power BI community forums. And whenever you have a difficulty, you can discuss with them, you can discuss with different people with expertise, and you can support each other also. Even within this training group cohort, you can you can exchange your contact information and can work together even in a project. You can share one data, select one data, and put a timeline for it, and work as a team. In that case, you can support each other and excel. Like I said earlier, those trainings, whether it is a 2-hour training or a 1-week training, that doesn't make you a Power BI expert. What makes you a Power BI expert is using this information, this highlight training, the induction, I call it, and build a real project of your own. I hope you have data. If you don't have data, there are many. Last week, Benga was showing you where to download publicly available big data sources. Download one of the data from there and build a real project. In that case, you will learn a lot. Otherwise, those trainings, 1 week, 2 week, 4 week trainings will give you the basics, the highlight, and guide you, but it will not make you a Power BI expert. So that is advice I have, and I hope you have this. You can go through it, and if you have any question, I have my LinkedIn address. You can text me anytime. I am available to support. Sorry for the time. The concept is big, and actually these DAX functions, there are so many, and understanding, mastering them will take time. But for you guys, I don't think it will be difficult if you really are committed and have few hours a day or a week committed and work on it. That would be very, very easy. So with that, I am concluding our training for today. I'm seeing a hand. If it is a question, please go on. Or if it is a question for the coordinator, please continue. Back to you, Benga. Over. Thank you very much. I appreciate it.
Yeah, so before we ask any question, can we just say thank you and appreciate him? I think you can drop your appreciation in the chat. You can show an emoji to signify how you appreciate what he has done today. I'm not trying to overhype Michael, but if you will hire a Michael as a consultant, I'm not sure his rate is going to be less than $200 per hour for you to hire him as a consultant. But he has given us about 2 hours plus today, and he has distilled very complex data and simplified it to the simplest language ever. Thank you so much, Michael. We so much appreciate what you've done, what you've invested in everyone on this call. So I wouldn't know, Bright. I know Bright is one of the very committed members of this community. Before, Mike, Bright, you have your question, but I want every one of us that can put on our video. Can we just put on our videos? We want to do a group picture with Mike. Mike, please put on your video. If you believe that your video is very fine, Mike, you can stop sharing so that I can put it in. Sure. Stop sharing. Everybody has the training guide. We can see the professionalism, okay, so please, excellent. Thank you so much. Please put on your video. Put on your video if you can. I can see 4 of us. Excellent. I can see people using good background. Excellent. Thank you. I'm waiting for, I want us to have enough so that we do the snapshot to be sure that is a real training. Let me see if I can pin Mike. Yeah, I'm pinning Mike, who is our trainer for today. Excellent. Great. Thank you so much, Adiwali Ogunaike. Thank you, Andrew. Thank you, Lutayo. Dr. T. Thank you. Thank you, Alex. Excellent. I love what I'm seeing. Let me see if the picture is coming out well. Okay, great. So thank you so much, Michael. Yeah, so yeah, okay, great. Thank you. Thank you. There used to be a princess that is very committed. I can't see in the picture. Okay. Okay, yeah, if your camera is not good, you're excused. We just want to be sure that everyone is captured. Thank you so much. Okay, great. Yeah, let me see the last one. I think I've taken enough good pictures. Wait, there are final phases that are coming up that I don't want to miss. Okay, great. So thank you. Oh, I can see one of the finest innovators of our time, Buddy Geshin. Let me take your screenshot and allow you to show in this. Okay, I think we're good. We're good now. So thank you, Mike. Bright, let me allow you to ask your question. I asked you to unmute. Have you unmuted?
Okay, good evening, sir.
Yeah, good evening, Bright.
Okay, first of all, I want to thank Mr. Michael for the wonderful lecture. But my question right now is, in data modeling, apart from using business data like product, sales, and customer data now, can it be applied to health data? I don't know if you got me, sir.
Yeah, sure.
Can
So,
the
Brian,
modeling be applied to health data?
Yeah, I understand. So, in short, the answer is yes. This is just an example. So, most of the time when you do have this kind of training, the composition is different. Some people are on health, some people are in business industry, some people are in education, agriculture. So there is no common data which represent everyone. So, but most of the time we use this business data. It is at least common for all of us. For example, I am in public health, but still I have some transaction with buying something. I'm a customer to one of maybe the organization to sell something or to buy something. So that is the reason we used this product, sell, whatever. But if I bring it to public health, for example, let's say we have immunization program. So in immunization program, we have, let's say, countries in Africa. If you want to know the immunization coverage in Africa, countries will be a table by itself. So that country will have the country name, the country code, the shortest name of the country, the geolocation, if you want to have mapping, so that means the latitude, and so on. And the other table might be, let's say it is coverage table. So in that coverage table, I will have that country name or maybe the ID to link the two tables. But here I will have the long details of the different columns having coverage for the different immunization antigens. And then there might be another table showing the population of that country, population table. So that population might have the general population, the under 5 population, the infants, the under 1 children eligible for immunization. So if you want to do coverage, you might need to calculate the immunization performance reported over the eligible population for immunization. That means you are picking data from 2 different tables. But if those 2 tables are not linked together with that modeling relationship, you can't do that. That is the reason why we need the modeling. This one is just an example, but it applies for every data type. As long as the 2 tables or the 4, 5, 6 tables have something in common with the fact table, the one which should be in the middle. We said we have dimensional table and fact table. So all those dimensional tables should have something in common with the fact table, so that the 2 can be linked either 1-to-1, many-to-many, or many-to-1. I think that answers your question, Bright.
Yes, it does, sir. It does, sir. Though I will actually have to get some video that has stuff like that so I can see how it goes. Sir.
Sure.
Thank you, sir.
Yeah, so thank you. Thank you, Brian. Thank you, everyone. I think this is a very convenient place for us to stop today. For additional information, I would encourage everyone who has been very diligent in this to visit the website www.sianalytics. There are emerging information that are coming out. You'll get to know about new programs that you can benefit from. So if you want to continue to improve your skill sets in data analytics, I want to encourage you to visit that website and sign up for every opportunity that is available to you. So we're going to stop recording this. We will upload it. We will share it so that you can watch it over and over again. So throughout this week, we're going to be focusing on ensuring that we understood all the concepts that we've had before the day one, on day one, and on this second day, because there's a lot of things that are loaded in this second day. You have the training guide. I would encourage you to watch the videos, pause the video, take the practice and exercises that are embedded in the training guide, and build confidence and competence ahead of our third live session, where you will see a live creation of a Power BI dashboard. At that time, you might not be able to ask a lot of questions because we're building it, you'll be looking at it. And if you miss the earlier concept, you might get lost along the way. So let me congratulate you for making it far to this point. I wish you all the best, and I wish you a fruitful week ahead. Thank you to our facilitator today, Michael. Awesome, fantastic, great session. Thank you, everyone. Let me leave you to go. Thank you, thank you, thank you, thank you. And thanks to SI Analytics for providing this platform for us to improve and to become better in Power BI and data analysis. Bye, everyone. Thank you.